In the beginning of the chapter, we looked at 6 formulas that we worked with. The first one for percent increase, second one's really the same thing for percent decrease. We did our doubling stuff, our half-life problems, our compounded interest, continuously compounded interest. We now have to look at word problems that involve logs, and the good news is there are no new formulas. The formulas we learned about in the beginning of the chapter are still the same formulas we're going to use for the problems that will somehow involve logs that will make more sense in a moment. I get it. Have a seat and hold on. As I did mention in the beginning of the chapter, these formulas by the test will need to be memorized, so for next Thursday's test, you will need to have the formulas memorized. For now, I would like you to read the example, and I want you to do part A because that is nothing new at all. I could have put part A on your quiz that you took on this stuff, and it would have been just fine. Read A, do it, do not go on to B. And you're going to want your calculator out.
Why do we have to show every step?
Because that's the direction, but not right here. Right now we're on page 32.
Is this part or what is this?
So we have to figure out what formula we need to use.
I don't know what to use.
Okay, Megana, what's the hint to figure out the formula? It's the percent increase decrease section, so we're going to use the percent increase or decrease formula. Now, no, you will need to kind of look at the problem and figure out, is something doubling? Is something getting cut in half? Are you investing money in a bank account? That's the bottom two. Otherwise, it's just percent increase decrease. This is the percent increase formula. That first formula is what we're going to use. Do we know the starting value? What is it? Not 3,000. Hat off, please. And what is it? 13,000.
I got it now.
635. Again, hat off, please. Thank you. Now, 1 plus. I am not going to use 4.5.
You're not? You're going to use 0.045.
0.045. Always the percent turned into a decimal. Please have a seat. Nathan, please have a seat. 0.045. And then 5. Because we're starting in 2016, how many years later? This is nothing new at all. For the work I need to see, you show me that, you go to the calculator. That's all I need.
We round up for the people.
You're going to round to the nearest whole number. Because again, this is just an estimate. Hopefully 16,992 people. Round to the nearest whole number because we're talking about people here. Round to the nearest whole number. Now, excuse me. In part B, this is different. By what year will the population be double what it was in 2016? Well, do you know what the population will be when it's double what it was in 2016?
Yeah.
Of course you can figure that out.
227,000.
How about we just do 2 times 13,635 and type it into the calculator? 27,270. That's not what the question was looking for, but I'm going to need that number for something. I know the starting amount. I know the A value, 13,635. I know my rate. It's the same as before, that 0.0451. I'll just jump to the 1.045. I already added them. What's the time? We don't know it. So it's going to be T, like Eva just said. But I do know the ending amount. The ending amount is 27,270. Okay. Well, if you don't know a power, how can you find a power? Everything we've been talking about in this unit, we need logarithms to get the power. Honestly, this is really just an exponential equation like we had in the homework. Can we move on? This is an exponential equation like in the homework. I need to get this piece by itself. Easy first step, I think. What do you do? Yeah. Divide both sides by 13,635. Oh, and actually, this is a really easy division problem. I know what that answer has to be without my calculator. 2, because that's kind of how we created that number in the first place. We're going to get the equation 2 equals, actually, why don't I write it the other way? 1.045 raised to the t equals 2. I just switched the order of the sides. 2, and then this thing over here. I am not going to take the square root. Who can raise their hand and tell me what I have to do next? Raising your hand, like Duda did. Of 2. This is just our convert it to log form stuff. When you don't know the power, we need to rewrite the problem in log form. We'll go to your calculator, figure out that log, and that answer will give us the time. And we're going to round to the nearest thousandth for this. Actually, no, we're not. We're going to get a time, we're going to round, and then we'll figure out what year it's actually talking about. I think it's going to take about 15.747 years.
How did you get that?
I got lost.
You got what?
How do we type in
Lost. Okay, so we want to solve the equation 1.045 to the t equals 2. So I'm going to write this thing in log.
I had it flip. So when I tried to do that arrow thing, it
Okay, so the arrow trick will only work if the exponential part's on the left, which is why when I went from here to there, I just switched the sides of both things. When you do that, it should become log base 1.045 of 2 equals t. Does that take care of it, Nathan? Equals t, equals what was in the power. Right? So then do your log base 1.045 of 2, and you'll have your time. 15.747? Okay, so now, what year is this talking about?
2032.
By January 1st, 2032, yes, that will be good. Or we could say it's going to happen somewhere in the year 2031, kind of towards the end of the year, because 15 years and 0.747 of a year. I kind of don't even like that question. I'm going to say in the year 2031, definitely by January 1st, 2032, our population will be what we want it to be. How about on the test or quiz, I just ask you how many years it will be, and you're going to say 15.747.
years.
Because then we don't have to bother with
Years.
this.
You need a,
Well, right. But if I ask for the year, you just give me a number.
on the test though, you said you have.
Then you would say years. You would have to put units. Because it's different if it's days, hours, and whatever. Okay. I would like you to set up the next example. Don't do any solving. Just take the formula, plug in the numbers, and then stop. Example on the bottom of the page, plug in the numbers and stop, please. Heather, do you have the numbers plugged in? Kayla Soldi, do you have the numbers plugged in?
Y equals 899. In parentheses, 1 minus 112 parentheses, 2 power.
Yep. And what is y? Do we know the final amount?
Oh, 800.
Good. We can plug in that final amount. When we're dealing with these, we will know everything but one variable. In this case, it's the time that we don't know. Well, we might as well do the subtraction problem. So maybe 0.888 inside there. Now, when you divide both sides by 899, does it divide in evenly?
No.
To make this as exact as possible, why don't we just say that 500 divided by 899 is 500 over 899? Why don't we say 500 899ths equals 0.888 raised to the t? Claire, you look confused.
No.
Should I try some of that again?
No. Oh, good.
I think moving forward, it's going to be easier if I just switch the two sides of this thing so we can do Mrs. Eburn's loop trick. I'm going to make this point 888 to the t equals that fraction. See if you can finish this thing. I think you can. I think you can. Okay, maybe not you, but... Oh my gosh. Well, you're the one whining.
I got that on camera.
Exactly. Prove me wrong.
Prove me wrong.
I think you can. You do not. You're going to rewrite it in log form. Okay, you two, stop. Do not do that. Eli, what's the base? Log base what? Log base 0.888 of what? Equals? T. Yes?
1.939.
Who has typed this in and has an answer? Shreya. Can't hear you. 4.939 years. So what I kind of want you to realize from these is the formulas are the same that they were before. It's just now we don't know the power. And we're going to solve for the power the same way you did in the homework that was due today. They're exponential equations. We're going to write them in log form and then go. However, the doubling ones are a tiny bit different because the power is not the time, it's the number of time periods. Let's take a look at the top one on the next page. And we're going to do this one together. Population of kangaroos doubles in population every 7.8 years. There are initially 32 kangaroos. How long to get to 100 kangaroos? So, y equals a times 2 to the x is the formula I'm going to use. Why would I think that that's the formula? It's a doubling time problem. Okay. Preston, how will I fill things in?
100 equals 32 times 2 over 7.8.
Let's make it simpler. Let's just make it 2 to the x. Let's just leave it as the x for now. But what you were talking about will work. 100 equals 32 times 2 to the x. We're ending with 100. We're starting with 32. We'll go from there. Okay. Well, I want the 2 to the x by itself. So, divide. It won't go in evenly, so just leave it as a fraction to make things as exact as possible. And I'm going to say 100 over 32 equals 2 to the x. And I'd rather write it the other way, so 2 to the x equals 100 over 32. Go solve that thing, find x, but don't circle that as the final answer. We're going to have to do a little bit of thinking to the answer that we get to get our true final answer. Question, Katie? It's in exponential form. If it was me, I would draw like a loop thing. That's what we're going to have to figure out in just a moment. So hold on to that. Does 1.644 look correct? Years? What is the power in? So hold on. What did we just find? What does this number tell us? We would have called this before, number of time periods. And Nathan, you were going to say a moment ago what to do. Yeah, a time period 7.8 years. Actually, what you were saying even before that was this is the number of like 7.8 years. Sure, so multiply that by 7.8. And we'll have an answer in years. That is not what I meant to do. Multiply by that. We should get 12.823. Hold on. I did not do what I said I should do. We need to use the whole thing that's still in the calculator. We're going to multiply that whole thing by 7.8, 12.822 years. Okay, so like before when we would do the doubling problems, if I told you it doubled every 3 days, how much will you have in 12 days? We wouldn't put in 12 for the power. We would put in 12 divided by 3, 4 time periods. It's the same idea here. We solve for the power, but that's not the time. It's the number of time periods, the number of times it's going to double. It's going to double 1.644 times. Well, it doubles once in 7.8 years, so multiply that by 7.8. Questions here? 1.644 time periods to go from 32 kangaroos to 100 kangaroos. And then we can convert that to how many years? I'd like you to try the next one on your own. It's a half-life problem, but it's actually very, very similar to what we just did. See what you can do. I think you can figure this out. Well, you're going to get the review packet at the end of today. We'll spend our usual 1 period going through stuff, but you're going to need to do a lot of that on your own. And actually, there are some things we're not even going to really need to review anymore. We're not going to have to review the formulas anymore because this is kind of the beginning of the review of the formulas. We're just finding the power rather than just straight plugging in. I hope that this is the equation you're working with. 1 equals 10 times 1/2 to the x. Divide. I think the log equation will look a little weird because of the 2 fractions, but I think we should be able to handle it. I'm just going to switch the sides just because it looks a little better like that. Cameron, did you have that equation?
Yep.
Can you tell me how you're going to rewrite it? What's the next step?
Log of 1/2.
Let's say log base 1/2.
Base 1/2 of 1/10.
There you go. Of 1/10 equals
X.
x. Byron, did you have that?
Yeah.
What do you have for x?
3.322.
3.322. Perfect. Days?
Time period.
Time periods. The power we find with these is always time periods. Claire, you really look like you have a question. Are you sure? Okay. Okay. And Byron, how do we finish it then?
You multiply by 12.5.
Perfect. 12.5. What are you gonna get for the number of days?
41.524.
Is anyone else getting 41.524 days?
I actually did.
Question, Philip? What's your question? Okay, so let me talk through this one more time. And now I need you listening. Excuse me. It's a half-life problem, so I'm going to use the y equals a times 1/2 to the x formula. A is the starting amount. You're starting with 10 milligrams. You're ending with 1 milligram, so 1 equals 10 times 1/2 to the x. I need the exponential piece by itself, so I'm dividing both sides by 10, and I'm going to get 1/10 equals 1/2 to the x. It's going to be easier to use Mrs. Eburn's trick if I switch the sides, so I'm just going to make it 1/2 to the x equals 1/10. Go into log form, log base 1/2 of 1/10 equals x. You're okay now? We got the time periods. You multiply by the time, go from there. Read the bottom example, but don't do it yet.
So it's not.
There is something a little different. So what?
It's not X over 12.
I can't hear you.
It's not X over 12.5.
No, so that's what we would do before to find the number of time periods. Now, we have the number of time periods. I want to go into time. That's the difference. There's a problem with this one. What's the starting amount? Okay, what's the ending amount? Excuse me.
10% of it.
Okay, what's the initial amount? You don't know. Okay, so let's see what we can do here. I'm actually going to use a different number, but you're going to see that what you just said will completely work. Let me show you one way we can do this. Why don't we, this is going to sound strange, but go with me on this, but I need you looking up here and listening. I'm going to make up a starting amount. Excuse me. Excuse me. I'm going to make up a starting amount. Please leave that alone. I'm going to make up a starting amount. I'm going to pick a nice round number, like 100. Let's say you're starting with 100 grams of something. If we're starting with 100 grams, what are you going to end with? What's 10% of 100? 10. No, we should be able to do 10% of 100. If I fill these things in, I'm going to get the equation 10 equals 100 times 1/2 raised to the x. Next step is to do what? Not yet. What's the next step? Divide by 100. Here's the point. Here's why it's okay that I made things up. 10 divided by 100, either 1/10, or I guess we could give the decimal if we wanted, because it's an exact decimal of 0.1. Yep. What was that? What was that? It's, let's say you started with 200 grams. What's 10% of 200? 20. You would do 20 divided by 200. You'd get the same number over here. Let's say you start with 1 gram. You'd end with 0.1. 0.1 divided by 1. 0.1. So it doesn't really matter what we start with. We're still going to get the same equation. You should get the same equation. Oh, what do you know? Yeah, it actually is the exact same problem well, last step's a little different. But yeah, the log is the same log that you did before. So it should be really easy now to convert to log form. Go convert that to log form, please. And then when you're done, remember, we don't want the time periods, we want the time, so you have something to do to that. Very, very quickly. Because I still need to pass out some things and wrap things up.
What am I gonna I can do that stuff.
So I'm getting about 3.322 for the number of time periods, which is the same thing we did get before.
Therefore,
Do what?
answer is
Do what, Claire?
multiplied by 300 years.
Oh, it's multiplied.
Oh, very good.
Does this make some sense? There are several different things you're going to see in the homework tonight. It's going to start with a few more of the addition or subtraction log equations because I want you to have a little bit more practice with those. Then you're going to do a few of those natural log and E equations like we did before lunch. And then only 4 word problems. Because we got as far as we did, which I was really hoping we would. So Thursday we're just going to do SAT things. Don't forget cumulative reviews are due Thursday. If you're not here because of MCAS, make sure you drop it off either tomorrow or Thursday. Hold on, don't pack up yet because I still need to tell you a couple things and I still need to give you some things. Monday, we have like 5 minutes of notes left to do. And then we can start our review on Monday. I want to do a bunch of word problems we're going to do a little activity with. We're going to review for our quiz, which will be Tuesday, on all the different types of equations. I'll basically give you a practice quiz that you'll do in class. If you can do that, you'll be able to do the quiz. We are finishing Monday, quiz and review day on Tuesday, and then test on Thursday of next week. I'm going to pass